This is Module 17, Section 6.6. In this module, we're going to look at solving quadratic and other nonlinear equations and complex numbers. In this particular section, we're going to look at quadratic equations. Quadratic equations are equations whose highest variable power is 2. Some examples of quadratic equations are shown below. X squared minus 3x plus 9 equals 0. Again, notice the highest power is 2. 3x squared plus 4x is equal to negative 2. Again, notice the highest power is 2. It doesn't matter where the other terms are in terms of the equal sign. X squared minus 9 equals 0. And x times the quantity x minus 4 is equal to 8 is also a quadratic equation, which is not quite as straightforward as the above 3, but when you distribute that x, you can see that x times x is x squared, and then x times minus 4 is minus 4x, giving you, once you remove your parentheses, an obvious quadratic equation. Highest power is 2. The standard form for a quadratic equation is ax squared plus bx plus c equals 0, where a, b, and c in that equation are real numbers, and a cannot be equal to 0. Of the above examples, only the first of the above examples is in standard form. So this equation right here is in standard form. While the other equations are quadratic equations, they are not in standard form. So to solve quadratic equations by factoring, we first need to review our factoring rules just very, very quickly. So a brief summary of factoring is as follows. The first thing you always want to do is look at an equation and factor out a greatest common factor if possible. After that, look at the number of terms in the polynomial that you're trying to factor. If there are 2 terms, try the difference of squares. If there are 3 terms, then decide what type of trinomial you have. If you have a trinomial where the a value is an understood 1, x squared plus bx plus c, then you're simply going to find factors of c that add to give you b and put it into binomial groups. If, on the other hand, you have a more complicated trinomial where a is something other than 1, or even if a is 1, there is a step-by-step method called the grouping method that you can factor those more complicated trinomials with, and we will review that. And if you have 4 or more terms, try to factor by grouping. Always factor completely, and it's always a good idea to check your answer by the FOIL method or the distributive property or whatever you like to multiply out polynomials to see if indeed you get the original polynomial that you started with. So let's review each of those quickly. Factoring out a greatest common factor. If I asked you to take these 3 expressions and factor out the greatest common factor out of each, notice that out of our first group, and this is basic elementary algebra, for our constants or our coefficients, we have a common factor of 3. And in addition, each term has a common y that we can pull out. Now, factoring is really like division. You're dividing it out. So 6 divided by 3 leaves us with 2 in that first term. Y squared, you took out 1y, you're still left with a y. And then to that, we're going to add 3y divided by 3y. Leaves us with a 1. In our second polynomial, we've got 8a cubed b squared plus 16a squared b cubed plus 20a cubed b cubed. Looking for a greatest common factor, starting with the coefficients. Out of 8, 16, and 20, there is a common factor of 4. We could divide out of each of those. For our factors of a, we've got 3 in our first term, 2 in our second term, and 3 in our third term. The number of a's that are common in all 3 is 2 of those, or a squared. And then b squared, b cubed, and b cubed, again, the amount that's common in all 3 is 2 of those b's, or b squared. Therefore, if we remove 4a squared b squared from each of those, 8 divided by 4 leaves us with 2. We had 3 a's, we took 2 out, so we're still left with 1, and we took both b's out. Out of our plus 16, positive 16 divided by 4 leaves us with a plus 4. We had 2 a's in the original term, we took both out. We had 3 b's in our original term, and we only took 2 out, so we're still left with a b in our group. And then 20 divided by 4 leaves us with a positive 5. We had 3 a's, we took 2 out, so we're left with an a. We had 3 b's, we only took 2 out, we're left with a b. And in factored form then, 4a squared b squared times the quantity, 2a plus 4b plus 5ab. Now, out of our third example here, notice that's what's common for each of these 2 terms is the group x minus 3. So just like with the above examples, if that's our common factor, then we're going to write that factor once, and we're going to multiply that to the group of whatever is left. In that first term, we took out the x minus 3 group, and we're left with an a. And in that second term, we took out the x minus 3 group, and we're left with a plus b. And that is the factored form of our third example. All right, so let's review factoring the difference of 2 squares. Now, the key to recognizing this is there will always be 2 terms, and the operation between the 2 terms will be subtraction, not addition. We're interested in the difference or subtraction of 2 perfect squares. So if there's 2 terms and there's subtraction between, ask yourself for each of those, are each of those perfect squares? Can you break them down into some factor times itself? And for this first example, the answer is yes. X squared can be broken down to x times x. Y squared is y times y. And the difference of squares always factors out into the product of 2 binomials. The first term in each group is the breakdown of the first term in the original polynomial. The second term in each group is the breakdown of the second term, so the y times y. And then in the groups, one is addition and one is subtraction always. If you wanted to check that, if you want to FOIL that out, our first 2, x times x is x squared. Outer product, x times minus y is minus xy. Inner product, positive y times x is positive xy, if we write that in alphabetical order. And last 2, positive y and negative y is negative y squared. Notice that our outer and inner terms cancel themselves out, and we're left with x squared minus y squared, which was indeed the original problem we were trying to factor. Okay, another example of difference of 2 squares. A squared minus 64. Notice there's 2 terms separated by subtraction. So ask yourself, could you break down each of those terms into the product of a factor times itself? Are those perfect squares? And the answer is yes here. This is a times a. 64 is 8 times 8. And therefore, this factors out to give a plus 8, a minus 8. All right, third example. Always ask yourself if there's a common factor that maybe you could pull out to simplify the problem sum. In this case, there is not. There are 2 terms separated by subtraction. Can you break that out into perfect squares? And the answer is yes. Now in this case, look at each of these individually. 16 is 4 times 4. Y squared is y times y. And therefore, 16y squared is 4y times 4y. Do the same thing on our second term. 81 is 9 times 9. Z squared is z times z. Therefore, 9z times 9z is 81z squared. And if we factor that, we now have 4y in our first group. We've got 9z in our second group. 1 is addition and 1 is subtraction. All right, so let's review factoring trinomials for a minute. If we have a trinomial that has a leading coefficient or an a value of an understood 1, then these trinomials are fairly easy to factor with not a lot of special steps involved. Okay? In order to factor these easier trinomials, we're going to try to find factors of our last term, which is c, okay? Factors of your c value that will add to give you your middle term coefficient, which is represented by the b. And if we can figure out what those factors are, those will be the last terms in our binomial groups. So starting with this first example, x squared plus 5x plus 6, can we find factors of positive 6 that add to give us positive 5? And the answer is yes. 6 will break down several ways, but one of them is a positive 2 times a positive 3. 2 times 3 is positive 6, but 2 plus 3 is a positive 5. Once we find those factors, if this is one of the simpler trinomials, we'll simply write our binomial groups. The variable in the problem will be in the first position in each group, and the factors that we just found will be the last terms. It doesn't matter what order, because multiplication is commutative. Doesn't matter which group is multiplied first. So we've got a plus 2 in one group and a plus 3 in the second group. If you FOILed that out to check it, first 2 would be x squared, outer product is 3x, inner product is 2x, and last 2 is plus 6. Combine like terms, and you get x squared plus 5x plus 6, which is our original trinomial. So looks good, checks out. That is the factored form of x squared plus 5x plus 6. All right, second example. Again, notice that the leading coefficient there in front of our y squared term is an understood 1. So we simply need to find factors of our last term, which is a positive 12, which will add to give us our middle term, which in this example is negative 7. So positive 12, there's several ways you can break down a positive 12. One of them is negative 4 times negative 3. Negative times negative is a positive. Negative plus negative, though, gives us a negative number, and in this case, negative 7. So to factor this trinomial, our y's will go in the first position, and our minus 4 and our minus 3 will go in our last position. We could check that with FOIL. Y minus 4 quantity times the quantity y minus 3. All right, this example, again, the leading coefficient is 1, so we simply need factors of a positive 20 that when you add them give you your middle term, which is a positive 9. So positive 20 can be broken down to be 5 times 4. 5 times 4 is 20. 5 plus 4 is a positive 9. So we've got x plus 5 and x plus 4 for the factored form of that third trinomial. But what about factoring a trinomial of the form ax squared plus bx plus c, where a usually is something other than a positive 1. Okay? When factoring the more difficult type of trinomials, several different methods can be taught to students. Our text offers 2 methods, the trial and error method, which in your textbook is in section 6.3, and the grouping method, which is discussed in section 6.4 in your textbook. We are going to review only the grouping method, as it will work for all factorable trinomials and minimizes guesswork on the student's part. Also, note that the grouping method will work for the easier type of trinomials too that we just reviewed, the x squared plus bx plus c, as long as you recognize that a equals 1. So if you don't want to memorize 2 separate methods for each of the trinomial types, the method that we're going to talk about next will work for all of them, even the easier ones, as long as you know that a equals 1 for those easier trinomials. So to review the grouping method, the steps are, first step, make sure the equation is in ax squared plus bx plus c form. Make sure it's in descending power order, write your squared term first, and then your x to the first term second, and then your constant last. Then your next step is you're going to look at the a and c value in your trinomial and multiply those together. Find the product. Then after you find the product, find 2 factors of that product which will add to give you b, which is very similar to what we were just doing with the easier trinomials, except that we're no longer just looking at the last number, we're looking for this product. The next step is different as well. Once you find the factors of a times c, which add to give you b, you're then going to rewrite the bx term in the original expression as a sum of the factors you found in step 3. Okay, so you don't just plug the numbers into your answer like we did before. You actually put them into the original trinomial and make a polynomial that is now 4 terms. When you do that, and if you do that correctly, you then should be able to factor that trinomial by grouping. All right, so let's look at this problem. This is ax squared plus bx plus c form. So we're going to look at our value for a and our value for c, and we're going to multiply those 2 coefficients together. Carry the sign with it. Okay, so a in this case is a positive 6. We're going to multiply that to a positive 2, which of course gives us a positive 12. Now we want to find factors of positive 12 that when we add them, instead of multiply them, it's going to give us our middle coefficient, or our b coefficient, positive 7. So factors of positive 12 that add to give us positive 7. That would be positive 4 times positive 3. 4 times 3 is 12, but 4 plus 3 is 7. Now, unlike the previous method, what we're going to do with that is we're going to come back to the original problem, and we're going to rewrite our middle term as the sum of 4 and 3. But since that middle term also has an x attached to it, we can't just write plus 4 and plus 3. We have to write plus 4x plus 3x. You want those 2 terms to add up to give you your original middle term in your trinomial. And you would agree with me that 4x plus 3x is 7x. The first term remains unchanged. The last term remains unchanged. But now we have a problem that has not 3 terms, but 4. So we're going to factor by grouping. Group in pairs. Factor out the greatest common factor out of each group. So out of this first group, we can take a 2 and we can take an x. So 6 divided by 2 is 3, and we still have another x left. Plus 4 divided by 2 is 2, and we took the x out, and so we don't have an x left in our group. Out of our second group, 3x plus 2, there's really nothing that's common that we could factor, so we'll leave it alone. But notice that's okay, because now our groups match. So our greatest common factor now is our group. So we're going to factor out the group, 3x plus 2, and multiply it to the group of what's left, which in this case is going to be 2x plus 1. 3x plus 2 divided by 3x plus 2 leaves you with 1, not 0. So make sure that you put a 1 in here, not a 0. This is your final factored answer using the factoring by grouping method. Let's do a couple more examples of that. 15x squared plus 17x plus 4. First thing you want to do, always make sure there's not a greatest common factor you could factor out. In this case, there is not. So we're going to multiply a times c. We're going to multiply our first term times our last term. So that's going to give us 15, positive 15 times a positive 4. And that gives us a positive 60. Now we want factors of positive 60 that when you add them, give you a positive 17. So 60 will break down several different ways, 1 times 60, 2 times 30. It also breaks down using 12 times 5. Positive 12 times positive 5 is positive 60, but 12 plus 5 is positive 17. So come back to the original trinomial, and we're going to rewrite that middle term as plus 12x plus 5x. You have to add the x in there because there's an x attached to that middle term. The first term does not change. The last term in the original trinomial does not change. Now factor by grouping, so group the first two together and the last two together. Out of that first group, we can take a 3 and an x out, leaving us with 5x plus 4. Out of our second group, there's no common factor, so it's going to remain as 5x plus 4. But that's okay because we have groups that match there. So we're going to factor out the group and multiply that to the group of whatever's left once we pull that group out. And that will be 3x plus 1. And that's the factored form of 15x squared plus 17x plus 4. Okay, 9x squared minus 6x minus 8. Take the first term and the last term, multiply them together, make sure you carry the sign. In this case, we're going to get a negative 72. Now we're interested in finding factors of negative 72 that will add to give us our middle term of negative 6. Again, 72 will break down several different ways. One way, though, is you could break it down as negative 12 times 6. Negative 12 times 6 is negative 72, but negative 12 plus 6 gives us negative 6. So we're going to rewrite that middle term as minus 12x plus 6x. First term in the trinomial remains unchanged. Last term in the trinomial remains unchanged. Group in pairs. Factor out any greatest common factors. Out of this first group, we can pull a 3x out, which leaves us with 3x minus 4. Out of this second group, we can pull out a 2, and that leaves us also with 3x minus 4. Our groups now match, so we can factor out that group, 3x minus 4, and multiply it to the group of what's left, 3x plus 2. And factoring four-term polynomials is a grouping method as well, which we just reviewed a little bit doing the more difficult trinomials. When you're factoring by grouping, you want to look for polynomials that have 4 or more terms. To factor by grouping, you always factor out any greatest common factor first, then divide the expanded polynomial into groups, which is usually in pairs, And do not put any parentheses after a subtraction sign. Factor out the greatest common factor from each group and factor out the common group if it exists. So let's look at some examples. Notice that our first example, xy plus xz plus wy plus wz, has 4 terms. So the first thing you want to think about is factoring by grouping. First, though, for any trinomial or any polynomial that you want to factor, ask yourself, is there a greatest common factor in those 4 terms? And in this case, there is not, but always look for it. Then if there's 4 terms, try grouping in pairs and factor out of each little mini group. In our first group here, you've got a common factor of x, so pull out the x, and that leaves you with y plus z. Plus, again, there's a common factor of w out of that second group, which leaves you with y plus z. Hopefully your groups will now match, and they do, so you can factor out the group and multiply that times the group of what's left after you factor out that original group. And in this case, that's x plus w. Okay, second problem. Y cubed minus y squared plus 3y minus 3. Is there a greatest common factor you could pull out? And in this case, the answer is no. So we're going to group in pairs and pull out any greatest common factor. Out of this first group, we can take not 1 but 2 y's out, or y squared, because there are 2 y's common to both. That leaves us with 1y for our first term in our first group, minus y squared leaves us with 1. Out of our second group, we can pull a 3 out, and we're left with the group y minus 1 again. That is a common group, so factor the y minus 1 group out, and that leaves us with y squared plus 3 in our second group. All right, let's look at solving quadratic equations by factoring then. To solve quadratic equations by factoring, we will use the zero factor property, which states if you have an equation that is set equal to 0, and this is the key, your equation must be set equal to 0, and you have multiplication in that equation that is set equal to 0, then the only way that equation can be true is if A is equal to 0 or B is equal to 0. Okay? Anytime you let A and B be numbers other than 0, like 3 times 5 or 1/2 times -4 or whatever, your equation will never be equal to 0 unless one of these two things is 0, if it's multiplication. So we're going to use that to solve these equations for x as long as they're set equal to 0. So over here, this first example, notice the quantity x plus 3 times, okay, so there's a multiplication step here, times the quantity x minus 2 is equal to 0. This is like A times B equals 0, where A is your quantity x plus 3, and B is represented by your quantity x minus 2. Now, zero factor property says, in order for that equation to be equal to 0, and it needs to be because that's what it says, then either A is equal to 0, or B is equal to 0, or they could both be equal to 0. So we're going to say exactly that. Okay? Either x plus 3 has to be equal to 0, or x minus 2 has to be equal to 0. Solve each of those equations for x, and you'll have solutions for x. So over here, if we subtract 3 from both sides, x is equal to -3. That's one solution. Or, if you add 2 here, x could be equal to a +2, and you also would get a true statement for that equation. So there's two possible solutions. X could be -3, or x could be +2. in order to have a true equation for that example. So for the second example, again, x times the quantity x minus 8 equals 0. Okay? Thinking about this as a times b equals 0, what that means is either a is equal to 0 or b is equal to 0 in order for that equation to be true. So say that. Either x is equal to 0 or x minus 8 is equal to 0. Now on our left-hand side, we've already solved for x, so there's no more work to do there. So x equals 0 is one solution. And over here, if we add 8 to both sides, x is equal to a positive 8 is a second solution. But what if the equation is not in factored form, like the previous two examples? Then, to solve an equation by factoring, these are the steps you're going to follow. Step number 1, set the equation equal to 0 if it isn't already. Step 2, combine any like terms. Step 3, factor the variable side of the equation. Step 4, set each factor equal to 0, as we did in the previous two examples. Step 5, solve each equation to get your solutions. And step 6, it's always a good idea for any equation that you solve to check your solution in the original equation to make sure you didn't make a mistake as you were solving it. All right, so let's look at this problem. X squared plus 7x plus 12 equals 0. First step, make sure the equation is set equal to 0. If this value on the non-variable side of the equation is something other than 0, this method will not work. So you've got to have the equation set equal to 0. In this case, this one already is, so we can move on to step 2. Combine any like terms on your non-zero side. Again, there aren't any like terms to combine in this problem, so we can move on to step 3. Factor the variables, the variable side of the equation. So we want to factor x squared plus 7x plus 12. That's one of those easier trinomial forms, x squared plus bx plus c. So you can use that grouping method, that step-by-step method that we talked about. Or if you remember, the easier way says find factors of c that add to give you b, and those will be the last two terms in your group if this is one of the easier trinomials. So factors of 12 that add to give you 7 would be a positive 4 and a positive 3. 4 times 3 is 12. 4 plus 3 is 7. And then, of course, the variable goes into the first position of each group. Now, once you have that factored, then you're going to set each factor equal to 0, because one of those factors has to be equal to 0 to make the equation true. And then solve for each. Subtract 4 from both sides. X is equal to a negative 4 would be one possible solution. And if we subtract 3 from both sides, x equals negative 3 would be a second solution. Now a quick check, just because that's a good habit to get into. If the original problem is x squared plus 7x plus 12 equals 0, and we want to check negative 4, you'd have negative 4 squared plus 7 times negative 4 plus 12. Now this is a check, so the question is that really equal to 0? Negative 4 times negative 4 is positive 16. Positive 7 and negative 4 is minus 28 plus 12. Is that equal to 0? And I think you'll find that 16 minus 28 plus 12 is indeed equal to 0. 0 equals 0, checks out, looks good. To check our second solution, we'd have x equals negative 3, so we'd have negative 3 squared plus 7 times negative 3 plus 12 equals 0. Negative 3 times negative 3 is a positive 9. Minus 21 plus 12 equals 0. And again, 0 equals 0, looks good, checks out, problem solve. All right, x squared plus 2x minus 8 equals 0. First step, make sure that the equation is indeed set equal to 0, and in this case it is. So combine any like terms, if there are any, and in this case they're not. So the next step is to factor that non-zero side. So this is one of the easier trinomials. So we want factors of negative 8 that will add to give us a positive 2, and I believe those factors would be negative 4 and positive 2. Minus 4 times a positive 2 is minus 8, but negative 4 plus 2 is a negative 2. So I'm thinking that those are the wrong factors. Let's try that again. We're interested in factors of negative 8 that add to give us a positive 2. So I still think that 4 and 2 are our possibilities. However, since we want the middle term to be positive, we will want the 2 to be negative rather than the 4. So 4 times negative 2 is negative 8, but 4 plus negative 2 is a positive 2. So we've got x plus 4 and x minus 2 equals 0. Set each factor equal to 0. X plus 4 equals 0, or x equals negative 4 if we subtract 4 from both sides. X minus 2 is equal to 0, or x is equal to a positive 2 if we end up adding 2 to both sides. All right, quick check on this one, and then I'll probably leave the checks to you from here on out. If we want to check x equals negative 4, we'd get negative 4 squared plus 2 times negative 4 minus 8 equals 0. Negative 4 times negative 4 is a positive 16. Minus 8 equals 0. 16 minus 8 is 8. 8 minus 8 is 0. 0 equals 0. This one looks good. If we put in a positive 2, we'd get 2 squared plus 2 times 2 minus 8 equals 0. That's the question since we're checking. Here we'd get 4 plus 4 minus 8 equals 0. And 4 plus 4 is 8. 8 minus 8 is indeed 0. That one also looks good and checks out. Okay, x squared plus 20x equals 0. Is that equation set equal to 0? Is there a 0 on the right-hand side? And the answer is yes. Or the 0 could be on the left-hand side. As long as your variable and constants are all moved to one side, it doesn't matter which side the 0 is on. Factor the non-zero side. So out of this problem, we don't have a trinomial. We have a binomial that has a common factor. So we're going to factor that x out. If you pull an x out, you're left with x plus 20 equals 0. And now that is factored form, so there's multiplication there. Set each factor equal to 0 and solve for each. On our left-hand side, x equals 0. There's not any more work to do. Over here, we have to subtract 20 from both sides. And x is equal to a negative 20 for our second solution. And I will leave the check to you. Third example, x squared minus 4x equals 32. First step, you have to move that 32 to the other side of the equation and set it equal to 0. So we've got x squared minus 4x minus 32 equals 0. Combine any like terms, but there aren't any. So your next step is to get that left-hand side, or the non-zero side, to factor. So again, this is one of the simpler trinomials. We're interested in factors of negative 32, which when you add, give you negative 4. And I believe those two factors would be negative 8 and positive 4. Negative 8 times 4 is negative 32. Negative 8 plus 4 is negative 4. So we've got x minus 8 times x plus 4 is equal to 0. We're going to take each of those factors and set them equal to 0. So we've got x minus 8 is equal to 0, and x plus 4 is equal to 0. Solve each. So add 8 to both sides here, and one solution is x equals 8. Subtract 4 from both sides here, and our second solution is x equals negative 4. And once again, I'll leave the check to you. All right, let's look at these examples. X squared equals 9. First step, it's got to be set equal to 0, so subtract 9 from both sides. That's going to give you x squared minus 9 is equal to 0. Combine any like terms if there are any, and there aren't. Factor the left-hand side. Notice that this problem is the difference of perfect squares. X squared is x times x, 9 is 3 times 3. So we can factor this out to give us x plus 3, x minus 3, and that of course is equal to 0. So set each of those factors equal to 0. X plus 3 equals 0, x minus 3 equals 0. Solve each, and we find one solution is x equals negative 3. And if we add 3 over here, a second solution is x equals positive 3. 3x squared plus 8x minus 11 equals 13 minus 6x. It has to be set equal to 0 to use this method. So we're going to subtract 13 from both sides to remove the 13, and we're going to add 6x to both sides to get our right-hand side to be 0. Now combine like terms on the left-hand side. We now have 3x squared plus 14x minus 24 equals 0. All right, first step on the left-hand side is to factor that left-hand side, seeing if there's a greatest common factor first. Okay? In this case, there is not a greatest common factor you can pull out of that trinomial. And this is one of the more difficult trinomials because there is a coefficient or an a value in front of the x squared term that is something other than a positive 1. So we're going to use factoring by grouping. We're going to multiply our first term, or our a value, times our last term. So that would be a positive 3 times a negative 24, and that product gives us negative 72. Now we're interested in factors of negative 72 that when we add them give us our middle term, which is a positive 14. And those two factors are 18 and negative 4. 18 times negative 4 is negative 72. 18 plus negative 4 is a positive 14. So we're going to rewrite our middle term. We've got 3x squared. Now instead of plus 14x, we're going to write plus 18x minus 4x. And then, of course, we still have the minus 24 on the end. Now we're going to factor by grouping. So we're going to group the first two together. Now be careful when you put in your parentheses for the second group. That negative, or that subtraction sign, has to go with the group. So go ahead and draw your parentheses so it includes that negative sign. Out of that first group, we can factor out a 3 and an x, which leaves us with x plus 6. And then out of our second group, because we want our groups to match, and notice that our first term in our first group is positive, we want to force that first term in our second group to be positive as well. So rather than factoring out a positive 4, we're going to factor out a negative 4. Okay? So that's going to take the 4 out, and it's going to change the sign of everything. So negative 4 divided by negative 4 leaves us with a positive 1x, and negative 24 divided by negative 4 is a positive 6. And notice now our groups match, which is good. So we've got x plus 6 times 3x minus 4. And remember, this came from our original equation where that factored side is equal to 0. All right, set each factor equal to 0. And we've got x plus 6 equals 0, 3x minus 4 equals 0. Solve each. X could be a negative 6, and the equation would be true. Or, if you add 4 to both sides, 3x is equal to 4. Solving for x could also be 4/3, and the equation would be true. So two solutions, x is equal to negative 6, x is equal to 4/3. Okay, this last example on this page, 7x cubed minus 7x equals 0. The equation is already set equal to 0. There are no like terms to combine. But what we can do is factor out a greatest common factor of 7x. So 7x cubed divided by 7x leaves us with x squared, minus 7x divided by 7x leaves us with 1. And don't stop there, because notice that now in your group you can factor further, because this is the difference of perfect squares. So now we've got 7x times x plus 1, x minus 1 equals 0. Now we have three factors, so we're going to have to set all three of those factors equal to 0. I'm just going to rewrite them here. 7x times x plus 1 times x minus 1 equals 0. Set each factor equal to 0. 7x equals 0 will give us a solution. X plus 1 equals 0 will give us a solution. X minus 1 equals 0 will give us a solution. Solve each. Divide by 7 here. X equals 0 is one solution. Subtract 1 here. X equals negative 1 is our second solution. And add 1 to both sides here. X is equal to a positive 1 is our third solution. All right, solve by factoring these quadratic equations. The quantity x plus 4 times the quantity x minus 9 equals 4x. All right, you might be tempted to set each of those factors equal to 0 and solve as written, because it looks like it's factored already. But the problem is it's not set equal to 0. And so therefore, this factoring does you no good. In fact, you have to undo that so you can combine any like terms, because that 4x also has to be over on the left-hand side. So let's FOIL that product out. X plus 4 times x minus 9. X times x is x squared. Outer product is minus 9x. Inner product is positive 4x. And last two would give you minus 36 is equal to 4x. Now I could combine like terms on my left-hand side, or I could choose to move my 4x first so I can set it equal to 0. And I'm going to choose to do that first, only because I can see that I'm going to get my 4x to cancel on either side, and it's just less work. So now I've got x squared minus 9x minus 36 is equal to 0. All right, now my goal is to factor my left-hand side. So I want factors of negative 36 that add to give negative 9. And that's an easier trinomial, so I can go ahead and just throw those in my groups. Factors of negative 36 that add to give negative 9 are negative 12 and positive 3. So set each factor equal to 0. And if we solve, we get x is equal to 12 as one of our solutions. And if we subtract 3 over here, x equals negative 3 as our second solution. 6y squared minus 22y equals 40. First step, set it equal to 0. Subtract 40 from both sides. So now we've got 6y squared minus 22y minus 40 equals 0. Factor the non-zero side. Notice that we can pull out a greatest common factor of 2 here, so we want to do that first. If we pull a 2 out, that leaves us with 3y squared minus 11y minus 20 equals 0. Now that trinomial is going to factor further, but it is one of the more difficult trinomials, so we're going to use that step-by-step grouping method where we multiply our first term and our last term together. So that gives us a positive 3 times a negative 20, which gives us negative 60. And we want factors of negative 60 that add to give us our middle term, which is negative 11. So factors of negative 60, which when you add them together give you a negative 11, I believe that would be negative 15 and positive 4. Negative 15 times 4 is negative 60, but negative 15 plus 4 is negative 11. So we're going to rewrite that trinomial, 3y squared minus 11y minus 20. We're going to rewrite that middle term to be 3y squared minus 15y plus 4y minus 20. Group in pairs. We can pull a 3y out of our first group, and that's going to leave us with y minus 5. We can pull a 4 out of our second group, which will also leave us with y minus 5. So now we've got the quantity 3y plus 4 times y minus 5 equals 0, and don't forget in the very first step you factored out that 2 right over here. All right, now that it's factored, we're going to need to set each factor equal to 0. Notice that when you pull a constant out, even if you try to set it equal to 0, that doesn't really make any sense. 2 is equal to 0 is not true, and there's nothing to solve for here anyway. You didn't pull a y out. So if you pull out or factor out just a constant, you don't need to worry about setting it equal to 0 because there's nothing to solve for anyway. Okay? Another thing you could say is you could divide it out and it would be gone anyway. 0 divided by 2 is just 0. Okay, so we are going to get two solutions here. 3y plus 4 equals 0. 3y equals negative 4. Or if you divide both sides by 3, we'll bring it up here, we've got y is equal to a negative 4/3 as one solution. Over here, if we take y minus 5 and set it equal to 0, add 5 to both sides. Y is equal to a positive 5 is our second solution. Okay, third example. X squared minus 26 is equal to negative 11x. We need to set it equal to 0, so we're going to add 11x to both sides. Now we've got x squared plus 11x minus 26 equals 0. We put the 11x in between because we need our equation in standard form. Ax squared plus bx plus c equals 0. Okay? Not a greatest common factor, but a simpler trinomial, so we'll go ahead and factor that out. We want factors of negative 26 that add to give us positive 11. That would be positive 13 and minus 2. And then our x's just go in our groups. Set each factor equal to 0. And x is equal to a negative 13 if you subtract 13 from both sides. Or here, if you add 2 to both sides, x is equal to a positive 2 for our two solutions in that example. And that brings us to the end of Module 17, Section 6.6 material. You should now complete the homework for Module 17, Section 6.6, found in my math lab, and when you have successfully completed the above homework, proceed to the video for Module 17, Section 10.6.